Wait a second. Roll that back.
This is what archaeologists are doing right now. They usually document their findings using hand drawings or sketches that are prone to errors. Oh, did we also say that this takes a really long time?
1 hour later.
Hi, we're working on the Mayan multi-camera project. Archaeologists have a very tough time mapping complex tunnel structures. To aid this process, we're creating a multi-camera system that is able to render a 3D visualization of the cave system. For this iteration of the project, we're using two brand new Intel RealSense cameras, the T265 and the D435. These are the Intel RealSense cameras. This is the T265 and this is the D435. The Intel T265 has two fisheye lenses that combine for around 170 degrees field of view. It also runs on-chip VSLAM algorithms that is useful and provides us with reliable tracking information. The D435 provides us with very reliable color and depth data.
To start off with, we had to synchronize the camera feeds coming from the two fisheye lenses from the T265 camera and the RGBD lenses from the D435 camera. We did this because when launching the cameras, the feed from the cameras do not have the same timestamps. Once we synchronize all camera feeds, we throttle the camera feeds, which means we are only capturing one frame every 4 seconds, rather than the default 30 frames every second. We used an open source tool called Calibre for the calibration process. For calibration, we used an April grid as a calibration target and recorded different poses and captured the April grid from different angles from both the D435 and T265 camera. The process roughly takes 5 to 6 minutes to capture around 100 frames. We had to find a sweet spot where both the T265 and D435 can clearly see the April grid.
For our SLAM implementation, we decided to use RTAP map due to previous success in the prior iteration of this project. From our camera calibration, we passed in a translation matrix and a quaternion matrix as inputs into our algorithm. These matrices determine the relative position of the T265 and D435 cameras when creating point clouds. The D435 camera is used for mapping the environment, while the T265 is used for tracking. Compared to just using the D435 by itself, the tracking is much more stable and accurate.
This is the legendary cave of Chesbob.
We start off with the three cameras, the fisheye camera and the RGBD camera. We take the feed from the two fisheye cameras and from the RGBD camera and pass it into a synchronization module. After the synchronized feed, we're able to throttle the frames per second of this feed. We lower the frames from 30 frames per second to 1 frame being captured every 4 seconds. We then use this throttled and synchronized feed to aid our camera calibration process. Once the calibration process is complete, we use a custom script to compute transformation matrices, camera matrices, intrinsic and extrinsic parameters of the two cameras. These are very useful to us because we can feed these parameters into our RTAP map node that is able to stitch together the tracking data from the T265 and the RGBD data from the D435. After the stitching is complete, we are able to generate a point cloud that we can then visualize.